In this video from chapter 5, we cover a small topic called accumulation functions. So I'm going to step off. Please pause, copy the material down in your notes, and then press play and listen to the explanation. All right, so an accumulation function is a rather simple object. So the accumulation function, little a of t, is a function whose output is the accumulated value at time t years of a $1 deposit made at time 0 years. So it's just an accumulated value for an initial time 0 deposit of $1. All right. Now, of particular note for us is the ratio equation here that says the accumulated value at time t plus k divided by the accumulated value at time t will always equal the ratio of the accumulation function at time t plus k versus time t. Now, this should not be a great surprise. Let's pretend the ratio on the left, the fraction on the left, equaled 1.2. That would tell us that my investment grew by 20%, the 0.2, from time t to time t plus k. Well, then my $1 investment would also grow by 20% from time t to time t plus k. The growth of the investment doesn't depend on how much you invest at the beginning, right? If it's 20% growth, it's 20% for Jeff Bezos investing $1 billion or little tiny a of t investing $1. They would both experience 20% growth, all right? So we have this very handy ratio. We're going to use it in 2 examples. All right, so we're given an accumulation function, little a of t is 1 plus 0.04t plus 0.003t squared. And we know that a deposit of $400 is made at time 3. And we'd like to know the accumulated value of the deposit at time 8. All right. So we're not given an interest rate. We're just given this version of how our money grows. It's a type of interest rate information. So we're told AV3 is 400, and we're trying to figure out AV8. And we're given the accumulation function. Well, I only really know one thing about the accumulation function. That's that ratio equation always holds. So I use 3 and 8. I know AV3. I know A of 8, and I know A of 3, so I can plug those things in, and then solving for AV8 gives me 527.29. Now, the fact that in our mind, the left-hand side, the deposit started at time 3 and not time 0 is irrelevant. All it means is that there's some unknown present value, which when you drag it forward 3 years would have been $400 at time 3. So we don't have to have investments that start at time 0 in order to utilize this ratio. All right, second example, same exact accumulation function. And what we'd like to know is the equivalent annual effective interest rate earned from time 3 to time 8. So if your banker says, look, invest money with me and I'll give you this accumulation function for growth, you might want to say to yourself, well, what does that mean in terms of something I understand more clearly, like an annual effective interest rate, right? So we're going to do a conversion. All right. If we are operating in an annual effective interest rate world, we have our happy, friendly, old-fashioned accumulation value formula involving a present value and 1 plus I to the t, right? We've had that for a while now. We've also got that handy-dandy ratio in our back pocket. So on the left-hand side, I'm going to apply the annual effective compound interest accumulated value formula, and on the right-hand side, the accumulation function that we've been given. So there's accumulated value at time 8 years using annual effective interest, accumulated value at time 3 using annual effective interest. There's A of 8 and A of 3, which I already had computed over here. So there's the value of little a of 8, and there's the value of little a of 3, which fractions out to 1.3182214. Present values cancel, and 1/8 over the 3rd power leaves the 5th power. Taking the 5th root gets me to this stage, and then solve for I gives me a 5.6812% annual effective equivalent interest rate to that accumulation function over the 3-year span over the 5-year span from time 3 to time 8. If we'd have done it from time 2 to time 8, we would have come up with a different equivalent annual effective interest rate for that.